And welcome to week 2, day 3. We have lots to cover today, continuing exploration of OpenAI Agents SDK and with our SDR project. So I want to quickly take a moment to recap what we did last time. We looked at tools by just using that simple decorator as a way to allow us to wrap a function into a tool and to be able to call that tool so easily without the boilerplate JSON that we needed to use in week 1. We then looked at the way that agents can also be turned into tools. By using the asTool function, we can simply change an agent into being a tool. And that turned out to be very easy indeed. And then, slightly confusingly, we saw that there is another way that agents can collaborate with each other, which is using handoffs. When you're creating a new agent, you can give it any number of tools, and you can give it handoffs. And I explained that the key difference between them is that when you're using tools, you can think of that as a call to the other agent, which will then return back. But when you're doing handoffs, you can really think of that as a transfer of control. The next step on the workflow is giving over control to that agent that is on the receiving end of the handoff. We're now going to go and extend what we did last time in 3 different ways, 3 things that will allow us just to learn a bit more about the framework. First of all, we're going to do what I promised we'd do and look at models other than OpenAI. So using the OpenAI Agents SDK to drive things like Gemini and DeepSeek. We're also going to look at structured outputs, the way that we can require an agent not to respond just with text, but to populate some kind of an object where we can specify the fields that are going to get populated. And then we're going to look importantly at guardrails, which are an approach to making sure that we have some controls over the information that comes in to our agent setup and what comes out. All right, with that intro, let's go back to Cursor, back to the lab. And here we are back in Cursor, and we are looking at the second week, and we're looking at day 3. Here we are, lab 3, week 2, day 3. And we're going to start by doing a sort of quick recap of what we did last time. We're going to do some imports. We're going to load the .env. We're actually going to bring in a bunch more environment variables than usual. I'm looking at a bunch of different keys here, Google, DeepSeek, Grok. Now, you don't have to do this. You can just stick with OpenAI if you don't have these other keys. But if you'd like to experiment with others, then this is the way to do it. And of course, if you have other things, perhaps you use OpenRouter as your way to connect to different models, you can be using any of these here. All right, now we have the 3 instructions for our 3 different sales agents. You'll remember one is more professional, one is more witty and engaging, and one is more concise. So in come our 3 instructions. We're now going to remember that we can use OpenAI's endpoints. We can use the compatible OpenAI endpoints to talk to other models like Gemini, DeepSeek, and Grok. And anytime that we have this approach, we will be able to easily use the OpenAI Agents SDK. So here we're setting the base URL for Gemini endpoint, the base URL for the DeepSeek endpoint, and for the Grok. These are their OpenAI compatible endpoints. So for Gemini, you can see it's got OpenAI in there. And the same for Grok. For DeepSeek, it is their only one. It's already OpenAI compatible. Then we create a new instance of the client by instantiating an async OpenAI object. As you can see here, passing in the base URL and passing in the key. And finally, we create 3 model objects. These are called OpenAI Chat Completions Model, passing in the name of the model and the client that we just defined in the group above. So this is a little bit boilerplate. And if you're using GPT-4o Mini, if you're using any of OpenAI's models, you don't need to do any of this because it assumes by default that this is the case. So what I mean is that when we actually create our agents, we're going to give them a name, instructions, and we're going to pass in one of these models. Now, if for this model you pass in a string, you just pass in text, which is what we did before. We just passed in GPT-4o Mini right there. If it's text, then it assumes that you're talking directly to OpenAI. But if, by contrast, you pass in a model object, an instance of OpenAI Chat Completions Model, then it will connect to this model using this endpoint. And so, as you can see, we have 3 agents, sales agents 1, 2, and 3. The first one is connecting to DeepSeek. The second one is connecting to Gemini. And the third one is connecting to Llama 3.3, the massive Llama model, through Grok, the fast inference platform. So there they are. This is how it all connects together. And we'll run that. And we now have these 3 agents connecting to these 3 different models. We will now do exactly what we did before. Our description, write a cold sales email, and we're now going to repackage each of those 3 sales agents into tools called Tool 1, Tool 2, Tool 3, and passing in this description as the description of the tool. And that is done. And we will now have a normal function tool. We use this decorator to reconstitute, wrap this function in the boilerplate JSON that describes this tool. And it's almost a wrap. We're zooming through everything we did last time. We now got some instructions. You can write a subject for a cold email. We've got some HTML instructions. You can convert a text email to HTML. We then make a subject writer, an agent, which is going to do this. And as I say, I'm just passing in the string GPT-4o mini. So this is an agent that can write the subject of an email. This is turning that into a tool that can write the subject of an email. This is an agent that can convert an email to HTML format. And here it is as a tool that could convert a text email body to HTML email. I know I'm going through this very fast, but we just did it yesterday. So hopefully this is just immediate revision. So we run that and we collect together those 3 tools. This is our emailer agent, the agent which is able to take some instructions, the email tools, and it has a handoff description, if you remember that. And now we're almost done. We now put these 3 sales tools into one group of tools. The handoff is now this one handoff agent, this emailer agent. We run that. And finally, here we are, the same arrival as before, the sales manager's instructions. We pass in the instructions, we pass in the tools, we pass in the handoffs, and we then write the cold sales email. And with that, I kick this off. It takes about a minute, and I will see you in a second when it completes. Well, I'm back, although it took slightly longer than I expected. So the run that I had just kicked off actually ended up taking several minutes, and it appeared to lose its way, going back again and again to get more and more emails generated. So I actually canceled it and ran it a second time, and it ran fine. But it is interesting. It's a cautionary tale to reflect on the fact that by their very nature, these autonomous agents are made this statement here. And this was the answer to the challenge from last time, that I say you can use the tools multiple times if you're not satisfied with the results. And that's really giving this kind of autonomy and potentially an infinite loop to the agent. And sure enough, I don't know if it was infinite, but we certainly had some kind of a loop going on. But I ran it a second time and it was fine. If I bring up the trace, here come the traces. This is the one that was going wrong. You can see it had run 14 tools and it was taking more than 300 seconds. If I bring it up, you'll see that it was going through sales agents 1, 2, and 3, and then back to 1, 2, and 3 again. And I can load more and on. So it kept going. Now you'll see that, of course, that Agent 1 is DeepSeek, Agent 2 is Gemini, Agent 3 is Llama 3.3. One of the things that I didn't point out last time that I would like to mention is that you can see that these are running in parallel. They are running, of course, asynchronously because they're very IO bound. They are waiting for information to come back from the API call. That allows async IO to be running multiple in parallel. But of course, the 3 run, and then it needs to sort of wait for then the sales manager will review those 3 runs and decide whether it wants to run them again, which apparently it did lots of times. And Llama 3.3, for some reason, took a really long time on one of them. So you can see there is inherent instability with these autonomous agentic frameworks, and that's something that you need to code explicitly for. Okay, but now let's just go back and look at the trace that did better. So this is the trace that just ran, and it took a rather more pleasing amount of time. And you can see that this time it only ran each agent once. DeepSeek, Gemini, and Llama 3.3, each one ran, each one came back with a response. That response was, of course, went to our handoff, went to the email manager that wrote the subject, wrote the email, and then an email arrived right here in my inbox. So all has worked well in the end. So I went through that code very fast because it's something that we saw before yesterday, so hopefully it was somewhat familiar. The new angle was that we were calling multiple models, and it was very easy because they are all models which have OpenAI compatible endpoints. Now, you may have noticed that there is one model that was missing there in the form of Anthropic's Claude, and Anthropic does not offer an OpenAI compatible endpoint. And so I understand that there isn't, as of today, an easy way to use Anthropic's Claude in lieu of those other models that have an OpenAI compatible endpoint. But there are plenty of workarounds. So there is, for example, a third-party provider called OpenRouter that a lot of people use that, and it allows you to set up your keys for other models, including Anthropic's Claude, and it has an OpenAI compatible endpoint. So you can go through OpenRouter to use Claude. Also, Anthropic has the incredible MCP protocol, which we'll be talking about in the last week, and that gives us another route to be using Anthropic through MCP. So more will come on that later. In the meantime, the easiest way to do this is to use models other than Anthropic for this purpose, and perhaps quite soon Anthropic's Claude will be available through the OpenAI SDK direct. Anyway, the next thing we're going to do is talk about both structured outputs and guardrails. We're going to do them together. And guardrails are ways that you can put a constraint around your agent platform. It's a test that you will do. And the cool thing about guardrails, I mean, you might think if guardrails were simply like a check of checking that something has given the right kind of results, you could just write that in Python code. You can just obviously test whether the results have a certain property in them or not and throw an exception if they don't. The special thing about guardrails here is that guardrails can themselves be agents, which means that you can use an LLM to be checking that things look good at any point in your flow. Well, actually, that's not quite true. When I say at any point, guardrails actually can only be applied either to the input at the very beginning, the input of the first agent, or the output of the last agent. You can't insert guardrails all over the place. You just have them at the very beginning or the very end, and they're designed to protect your model against getting an input which is inappropriate or not what it's intended for, and also to protect it against producing an output which should not be shown to the user. So it's those two extremes. That's where you can implement guardrails. And we're going to implement an input guardrail right now. But as you'll see, it's basically exactly the same thing either way. And I'll leave a challenge for you to add an output one afterwards. So the first thing I do, because we're going to be working with structured outputs, is I define a class called nameCheckOutput. We're going to be checking for names, for people's names, because we don't want people's names in our emails, we've decided. So we're going to have a nameCheckOutput, and this is one of these pedantic objects. If you remember, this is where you have objects, classes, which are designed to reflect a particular schema of data. So what we want is that we want the nameCheckOutput to be something which has two fields: is name in message, which is a Boolean, where true should mean that there is a name in this message. And name, a string, would be the name if there is a name in the message. Okay, so this is all we're doing here is we're sort of defining a schema. We're saying this is a particular structure of class that we want to think of. And now we're going to define an agent. And I'm naming it Guardrail Agent. You can name it whatever you want. We are going to use this in a guardrail. But this is just, as of now, just another agent we're creating. Its name is going to be namecheck. The instructions are: check if the user is including someone's personal name in what they want you to do. The output type, this is the structured outputs piece. We're telling this agent, we don't want you to output text, which is what you normally do by default. All of these are outputting just strings of data. But rather, we want you to output a namecheck output. We want you to output an object that conforms to this schema. And you can use this for any of your agents. So we could go back and use this as a way to structure our emails better. So we could use this so that rather than emails being just strings, they could actually already have a subject, a recipient, a body. We could do it that way from the get-go, and that would be much nicer. And that is in the challenges at the end. But for here, we specify the output type is name check output. And as before, we specify a model, GPT-4o mini. And that brings us simply to the guardrail. So a guardrail it's like an asynchronous, it's a coroutine. I was going to say a function, but it is, of course, strictly speaking, a coroutine. And you simply decorate it with input guardrail to say, I'm going to be using this as an input guardrail. It's a bit like decorating something to be a tool. And there's a completely analogous one called output guardrail, which is what you would use if it was to be used as a guardrail for the output. You can call it whatever you want. And it takes, the context is a bunch of data that you can pass between agents that we haven't made use of. The agent itself, and this is the input that's coming in. I've called it message. And so what we can do right here is we can, as part of implementing this guardrail, we can actually kick off this guardrail agent. We can run this guardrail agent, and it will be giving it these instructions. It will be passing in the message, and it will be expecting a name check output to come out of that. So this is basically going to do just what it says on the tin. It's going to check if someone's personal name is being included in the message. And then you have to return, the rule about writing these guardrails is you have to return something called a guardrail function output. That's always the thing you return, which is informing the system whether or not there is a problem. And it has two things. Output info is just a dictionary of stuff that might be useful for tracing. And tripwire triggered is a Boolean. It's true if there's a problem. You pass in true here if something has happened which should trip the tripwire and alert the guardrail has not been met and there is a problem. So what we're doing here is we're saying if this agent that we just ran, this agent produced an object of type name check output, if that has is name in message set to true, which means that this agent reckons that there's someone's personal name in the instructions, then that should trigger the tripwire. That should cause this guardrail to fail, and there should be a problem. That's the key. That's how it works. I hope that makes sense, and you could use exactly this structure. And then, of course, for output guardrails, it's pretty much the same thing, but instead of message, you would put the output there. Otherwise, exactly the same. All right, let's give this a try. Okay, the moment of truth. It's time to actually run a careful sales manager, a new sales manager. And this is an agent. It's named the same as before, sales manager. The instructions, same as before, sales manager's instructions, same tools and same handoffs as before, and the same model. The difference is right here. The difference is that we are passing in an input guardrail. Input guardrails is guardrail against name. And of course, you can also have output guardrails that will affect the final output. And what we're doing is we're going to make this message, send a cold sales email addressed to Dear CEO from Alice, and then kick this off. And no surprise, what we're doing here is we're passing in someone's name. And so we are expecting that the tripwire is going to get triggered because our guardrail is going to notice that there's someone's name in here. Now, you might be forgiven for thinking, okay, well, what exactly is the point in this? I can see with my own eyes that we're passing in someone's name here, and you could just call an LLM at this point or something. You know, what are you doing exactly? The point is that, look, we've hard-coded here the message that we're sending in to generate these sales emails. But the idea is that you'll be building this into a product. You'd have a product which would have a prompt, and your users, this kind of input wouldn't just be hard-coded in a notebook. It will be being typed in by your users, your sales team, a prompt to kick off their sales automation. And so the purpose of this kind of tripwire is to make sure that no one types in your CEO's actual name, or perhaps there'll be other PII, personal identifiable information like phone numbers that you'd want to make sure did not get put in your cold sales emails. That's the intention here. So whilst this is a little bit artificial that we've got it right here, The point is that this protection would apply to any input prompts that are coming in to your agentic framework. That's the purpose of the guardrail. So with that explained, we will now kick this off. We're going to run the careful sales manager, and off it goes, and bam, there's been an exception. You might think, bug in my code, but no, the exception is what happens when a guardrail is triggered. And what you'll see here is guardrail input, guardrail triggered tripwire. So something went wrong. And to look in more detail on what went wrong, I mean, something went right because something went wrong. We go in here, we open up the protected SDR, and we should see guardrail against name check. And we should see that this guardrail got triggered. The output is name in message is true, name is Alice. So indeed, the guardrail here was triggered, and that's why the process was stopped with an exception. So that is successful triggering of a tripwire, and hopefully makes some sense. And of course, to make sure you're convinced this is working, I need to show you an example with the tripwire not being triggered. So we can just call exactly the same careful sales manager, but this time the message is going to be send out a cold sales email addressed to Dear CEO from the head of business development. No more mention of Alice. And if I kick this off it goes, it's running. You can see right away that there isn't an angry guardrail that's being tripwired. And so that is running successfully. And in fact, I just kicked this off a moment ago as well. And so I already have my prior email, and here it is. It did indeed come back with a perfectly decent email, and you'll be pleased to see that it's signed off the head of business development. I'm interested to see it also has a copyright 2023, which is a slight sign of the results of knowledge cutoffs there. You could always try and add that as a tripwire, as a guardrail if you wished. So that is showing you guardrails working, and now some exercises for you to take this to the next level. Try some different models. We've tried Gemini and DeepSeek and Grok, Llama 3.3 through Grok. This has just finished successfully. And you can try more of those too and see the different kinds of models that you can use there, the variety. Add some more input guardrails and output guardrails. And then finally, we had our first exploration of structured outputs there with the Agents SDK. Try adding some more. When we generate emails, we could actually be populating one of these pedantic objects, a schema, instead of just returning text of the email. So try adding that too. That is obviously a more robust, more bulletproof way of doing it. And then experiment with this and get to a point when you're happy with your SDR. You could also put a user interface around it if you wanted. And that is an interesting business development tool. All right, that concludes our session on tools, agents, guardrails, structured outputs, and the like. Next time, we're moving on to our next big project, which I'm so excited about, building our own deep research. See you next time.